Structural Analysis 2, Chapter 8, Deflections using Energy Methods. In this example, we want to solve previous problem, but if you remember last time, we just calculate delta maximum for this kind of loading, and this is a two simple support beam. This time we want to calculate what theta A and theta B is. So let's see how we can approach this problem. So again, this time by having the equation of moment, but this time by integrating of moment, we can get the theta equation by having the boundary condition and replacing on theta equation. So if you have a C2 and C1 coefficient and then replace in theta equation for theta A, which L is equal to 0, you can replace x by 0, x by 0, and then C1 is constant. So theta at A is negative 5 times WL cubed over 192 modulus of elasticity, that's theta at A, and symmetry theta at B is also equal to theta A, and that's also negative 5, and negative is just the direction of the. Let's see, that was the integration method. Let's see what is the answer for virtual method. In virtual method, we already have the equation of moment from previous part by integration, and if you just apply a 1 unit moment at A to calculate theta at A. So if you want to calculate what at A is, we just apply a virtual moment for calculation of theta at A and create summation of moment about A goes 0, just gives us the reaction at B is 1 over L. Reaction at B is 1 over L. Summation of forces in y direction just simply says RA should be the same and in opposite direction. So this is our RA and this is our RB. As soon as we have the reactions, the virtual work method, it just says cut the beam through by a length of x. So as soon as you have that, just jump to mx to calculate the small m, which is mx is equal to 1 minus x over L. This is our equation for virtual work. And if you remember in virtual work, 1 times theta A or 1 times delta. If you have moment, that's 1 theta. If you have delta, that's a force is equal to small m, capital M over EI over the span of or entire the length of. So if we know our 1 theta at A is mx over EI, so we can easily know place the small m with the virtual moment, capital M by the real moment. Then if you replace in the equation, just gives you the answer of this integration is answer for theta. This is the integration. If you just integrate it, it's simplification of the integration, second line, and then it just comes to the answer of the integration. And if you do so, it just gives you theta at A is equal to this number times WL cubed over. If you make a comparison between the answer from theta at A, theta at B, this is from virtual work, virtual from structural analysis, and this is something like from integration method. If you do the math, it just you can easily see difference is almost negligible, and you can easily by each of these methods to calculate deflection and the mode A. And thank you, you'll solve more problems.